a fluid-like medium postulation that can't be validated.
Well, I would say
inherently.
I would say a more logical explanation of meteor showers is leftover dust and debris from meteors that have passed through Earth's orbit, and Earth is orbiting into these clouds of leftover debris from comets and meteors that cause a meteor shower.
That seems
not
way
a lot of
way
more
more
logical of reality.
That's a way more logical.
What's more logical to me is that we know that the Earth
Then there's
it has energy, right? It's
Electric
like this.
universe, energy,
we have a-
magnetic universe explanation that has. It's
Well,
not based in
everyone
any
will
empirical
acknowledge the
evidence.
electric universe within the 10 years. Most of you will just run with the heliocentric and try and bend it in there somehow. So
Yeah,
there's an electromagnetic field on Earth, and obviously if there's some type of perpetual motion with a toroid, then it would cause a circuit. If there is a barrier, which I certainly think there's some type of containment, then it appears there could be a fluid-like medium above us. Maybe the barrier is an insulator of sorts, and there could be occasional electrical discharges from the system and the fluid-like medium.
I counted 6 could be's in there. Sure, could be. Sure, please,
It's speculative. I just said that.
Yes, well, what's not speculative is that we know there's leftover debris fields from comets that pass Earth's orbit. This is not speculative. That's a huge distinction. No, it's not.
Friend, I think you know that we disagree whether or not that's speculative.
Yeah, of course we disagree.
Consider that empirical because that's not verifiable.
All right.
Is that verifiable, man?
Yes.
What's verifiable?
How can I independently verify?
Because
that?
we know. Because do you know the name of meteor showers?
I don't.
How they're
I don't
named.
study
and
the intricacies and details of the.
Okay, neither do I. But
I'm not a religious zealot.
Fun fact: the Orionids are peaking tonight.
That's kind of a joke. Sorry, it wasn't. Maybe you're not that funny. It's not that funny. But dude, no, I don't know. I don't know. What is it? Or whatever. I'm just saying, like, dude, there's an explanation they've come up with. It's based on a privation. It's based on all kinds of crazy stuff.
It's not
privation. He just loves using the word privation for all the time for anything.
Because that's the crux of the idea of space we have right now, dude.
Nothing is speculative about your electric universe, whatever theory where there's discharges that cause meteorites has zero is you admitted it yourself is highly speculative.
Well, yeah, but what you're saying doesn't even make sense. Mine does, because meteor showers in your paradigm would go in all kinds of directions. They'd go up in the sky. They'd look like they were going up. They'd go left. They'd go right. But they're always going down. Why do they always go down in the same direction?
I've seen lots of meteors that don't look like they're going down.
But they're falling down, even if it's at an angle, and they're all falling at the same direction.
I've seen some that look like they're going from the horizon upward.
You're just making stuff up, man. You're just a contrarian. So what I'm saying is, yes, I can see that this is speculative, and you have an explanation, I have an explanation. I consider mine more logical because all the electrical discharges would follow the same perpetual motion.
You have no explanation. Your explanation is it could be this, it could be that.
But you're claiming something that wouldn't happen because we're going multiple vectors, so our perception of meteor showers would be completely random based on the debris occasionally passing us, and they'd go in all kinds of different directions.
He just said, and they wouldn't have cut that because we're intersecting with them, so they would come from the same general direction. But what he said was correct. They don't just come. They almost rarely ever come straight down. I didn't
say straight down. They come down at an angle.
They appear to be radiating from a single point in the sky because
they're
parallel lines. And if you're looking up them, they appear to converge on a point.
Have you ever seen stick welding?
My specialty.
Are you scattershotting?
All right, well, just visualize stick welding. Add it into a fluid-like medium.
Imagine running your car into somebody else welding. Somebody else welding where they are. You're running your car.
Wow, you're combining the fairy tales. Doesn't that seem a bit intellectually dishonest?
That's we're intersecting this trail.
No, dude. Wait, okay, so I'm saying, I understand that you're saying they would all go in the same direction once they come into our sky together, but how come the next time they come to our sky, they're not looking like they're going up? Why don't they ever look like they go up in all of the history of mankind? How come no one's got any evidence of them all looking like they're going up?
They're never actually going up because they're coming from above us. They'll appear to go up in your field of view, depending on where the gradient is at the time in your sky.
Yep.
Wait, can you find the evidence of that?
It depends on your altitude. It depends on your latitude on Earth and the origin point for that specific given meteor shower.
Can you provide the evidence that they will go up?
Yeah, here's one. Here's a
There you go.
image with a bunch of them in the same frame. Some of those appear to be going upwards.
There you go.
Can I have like a video, man?
When the radiant's low on the horizon, more of them will appear to be going upwards.
You're showing me a still shot and telling me what direction they're going? What's cool is most of them, what's really cool is most of them appear to be originating from a single point on the sky. That's pretty awesome.
Almost like an electrical discharge.
Try to think about this, what you're requesting, like them coming from, you're imagining the horizon and something coming straight up in front of you, basically, near the horizon, or at least in that general direction. But if that were the direction that one of these were coming from, and we're intersecting that part of the Earth, that wouldn't be something that would end up in your sky. It would end up in the sky, on the other side of the world, basically. If the world was a globe.
Right, but I mean,
yeah.
Okay, yeah. I mean, I understand. But, dude, I'm just saying also, the reason that's my logical premise, or in my opinion, logical foundation is it would be consistent with sprites also. Y'all know what that is, right?
That's a completely separate phenomenon.
According to you,
completely separate phenomenon.
But do you see how I say they could be
How
connected?
come we've never seen? How come we've never? Sure, if in that highly speculative regime, yeah. So if you could find many pieces of observational evidence or empirical evidence that shows a correlation between sprites and meteors, then I'd love to see it.
Oh yeah. Do you think that Electric Universe has any potential foundation?
Not at all. Let me get back to the main point.
Well, you're just gonna have to swallow that pride eventually.
Yep. Back to the main point with the thing with Lemon. So this electrical discharge versus dome, chips off the old dome versus remnants of meteors that have passed through Earth's orbit, leaving dust and debris that the Earth orbits into. Those three, if you put those three ideas up against each other, the one that has the most foundational empirical evidence to back it up is the latter, the last one that I said, where nothing is speculative. We know the meteors that have caused this trail that have intersected Earth's orbit and left debris that Earth then orbits into. We literally know these meteors. We observe them. So there's nothing is speculative about it.
But the implications of the space narrative say that it came from some sort of asteroid belt, some sort of planet, or something else. That has not been confirmed. That's a
meteor showers typically come from the debris trail of comets.
How do you explain sprites?
Isn't that just?
Those are electrical.
Did what I said?
How do they have? What's going on there?
Hang on, you're talking about the electrical upward discharge from lightning?
Looks like it hits a dome barrier in some cases.
What?
Chronic, don't get too disappointed.
Wait, I wanted to hear what the other guy said, please. I'm sorry. What did you say?
It's all good.
Yeah, sorry, I was just trying to get the context of these sprites. Are you talking about the ejection that goes up from clouds when lightning strikes happen?
From clouds, sure.
Okay, so
there's a bunch of different ones. Sometimes they just kind of like appear to originate out of nowhere, as if there's something that's conducting that charge. Where there appears to be nothing there. Some of them just happen when there appears to be nothing there, though, but almost as if there's something conducting it that you can't quite see.
You're talking about
I've never heard of them appearing on their own. They're always associated with strong thunderstorms.
Of course, they're in thunderstorms. But they don't actually come out of the clouds. You just said that. They don't always come out of the clouds. You haven't looked into them. Okay, so what I'm saying is it's almost as if they're having some type of interaction with something that we don't see. But then it's like there's a fluid-like medium. So, hey, man, God forbid we actually look into things ourselves instead of just believing the theoretical framework laid down for us by authority figures. Even though they admit inherently it's theoretical and that they could be wrong, and that fast forwarding 20 years from now, we could have admitted we were completely wrong about everything. Even though they admit that, we're not allowed to try to come up with our own way because Austin dropped out of college and doesn't have credentials, and I didn't worship everything that they came up with thus far. And I feel like that's actually the opposite way to gain knowledge. I think that's actually the most inefficient thing we could possibly
Who
do.
are you
So when people say
talking
science is all
to?
about that, we need to figure things out. We need to keep on questioning the norm, right?
Talking to me.
It's just like I'm talking in
Talking
general
to
about
Okay,
people
just
with
like
sorry.
ears to
science.
listen.
The hell do you think he's
Yeah, and
talking
like
to?
example, Tesla was considered like Tesla dropped out of college and he was going against the whole fold, and then he ended up becoming very innovative. Just an example. There are now people that are talking about the electrical nature of the world. They're kind of minimalized, but like at least they're trying to come up with some of the problems that we have. At least quantum field theory is trying to figure out some things. This is
Right.
what's important: is that people try to figure stuff out, man.
Right. You know that in the electric universe, the Earth is still a globe, though, right?
Yeah, but that's
Oh,
what
nobody
they
gets
say,
it
of
all right.
course.
Mostly the globe is a metaphysical claim about matter clumping together, highly atheistic, highly materialistic. But the foundation of any philosophy needs to be tested for validity.
There's also some geocentric spherical electric universe models.
Geocentrics, you know.
Yeah, spherical geocentric. I've never
Yeah.
seen. Of course, you're not going to see mainstream on a TED talk of a flat Earth electrical universe. I mean, let's be honest. So anyway,
Well, since
but they're right
electricity
about a lot
is,
of things.
well, since
If you
electricity
explain
is
it,
the link.
it would be compelling. That's the end of the story. I mean, the flat Earth treats the globe side like one thing is that they're a closed book. They don't care. They don't want to listen to you. Now that's not true. Science is open for refutation, and I think that if you can acknowledge that, you know, that would be really great.
Science
Well,
is
okay,
open,
like
but
one of the
they're
most
working with a very
propped up
particular
people in your
goal.
paradigm that has a Nobel Prize. He was just interviewed the other day, or not the other day, but I saw it the other day, and he's sitting there and he got shocked the interviewer, who was another like prominent physicist, right? And I'll try and find the video if you want to see it. He's sitting there straight up admitting, well, Einstein wasn't right about everything, and you know the ether postulation seems to be resurfacing. I mean, this dude got a Nobel Prize in y'all's paradigm. It is becoming absorbed within your own paradigm that we're going to have to make a shift in a lot of the conceptual backing of what we think's going on. Even quantum, what do you think quantum field theory is? What is quantum foam? Like, dude, it's inevitable there's a transition going on, and for people to just try to like societally ostracize those that are, you know, trying to figure it out, I find to be counterproductive overall
That's
as a
totally
society.
fine.
Would
But
that be
I would
you?
say it's be more a refining, though, wouldn't it? It wouldn't be throwing it all out. I mean, there's not tomorrow. We're not going to be able to throw out Newton's laws of motion, are we? Those are quite clear.
Well,
You know,
those were contradicted by quantum mechanics, like in the early 1900s. So they're not quite
I
clear.
don't know if that's true.
Well,
Though. Is
Well,
that
I
true?
can cite that.
you know, Feynman talks about in quantum mechanics things are different. But when I'm talking about the real world, you know,
No,
that we
quantum
live in,
mechanics. Sorry.
in the Feynman lecture at the very end. I mean, QE cherry picked from it, but it did specify within quantum mechanics, you know, things change. But for all other intents and purposes, Newton's laws remain totally fine.
Right. It
What is
doesn't work on the
cherry
quantum scale. It's
Right.
not cherry picking. It just you need to specify. To be honest, it doesn't work on the quantum scale. Right. That's the point. Now, the reason that he phrased it that way, and you're saying it's cherry picking, but the reason that the guy phrased it that way is because it's under the application that for it to be an accurate natural law, it's going to have to apply at all scales.
Is it definitely true that Newton's three laws of motion don't apply? Because they're pretty simple.
Are you not listening?
They hold
You guys have said this, but
they don't apply on the quantum
apply?
scale.
Yes.
All three of them don't apply on the quantum scale.
The second one's like this. Okay.
All three of them don't apply on the quantum scale, Scott.
So there's things accelerate without a force on the quantum scale?
The three Newton's laws of motions are not applicable on the quantum scale. This is well known since the early 1900s.
I didn't think that was well known. I'm literally just asking for information. Asking you to explain it to me.
Yeah,
I'm curious about it.
The second law of motion is definitely applicable down there, and I think
Yeah,
in regards to the other two laws, it's just the way in which we understand quantum mechanics is in the sense of probabilities and things like Heisenberg uncertainty principle, things like that, with the not knowing the not being able to pair these certain quantum properties together, like the velocity and momentum and position. And so, you know, with those kind of limitations of what you can do. Of course, the other two laws aren't going to be applicable.
Wait, do you think 1, 2, and 3 are non-related? They're related.
I think
They're a package deal, dude. They're a package deal.
Indeed, different than the other two.
But the explanation can't be right because they're a package deal.
1 and 2
Quantum
are the
contradicted
same,
it.
and then 3 is like its own thing.
Quantum mechanics.
2 is just
dude.
describing what a force is. That's all 2 is.
Well, it's the axiomatic interpretation that for acceleration to occur, it requires force.
Right. So it's describing force. It's describing force and acceleration, and what force is in relation to acceleration.
Okay, but it's a package deal. The Newtonian physics is a package deal.
Yeah, it's not a package deal though. It's not like the whole thing's a package deal. But none of those.
Okay, I'll meet you. Well, yeah, we don't want to talk past each other, right? I don't want to talk past you, bro. Like, you're right. Like, just because Newtonian physics framework is wrong doesn't mean that the axiom claim of a force, or you need a force for acceleration, is wrong. It could still be right, but under the framework of Newtonian physics, it isn't right because it doesn't work on all scales. Because quantum mechanics showed this in the early 1900s. That's all I'm saying.
See,
Which goes back to my original point, though, right?
Hang on. Sorry. I don't think you're using axiomatic in the way it's supposed to be used there, WITSIT.
Yes,
no, I'm sorry. You keep saying it as... Hang on, Kosho, can I finish talking?
I'd rather you didn't.
Negative.
Conversation.
Go ahead.
No, let him finish because he's making a good point.
Of course, Zanik thinks so.
No, the thing is, every time you use axiomatic, you actually mean that it's to be true or factual. Thank you.
That was a shit.
Wow, what a loser!
That was a great point.
Look what Scott just put there. Newton was obliged to give his laws of motion as fundamental axioms.
You
Shut up.
To make a great point, and you made Kosho stop interrupting you, and you said
I didn't say great points, did I?
Scott's picture refutes what you just said.
Hang on. No.
Newton was obliged to give his laws of motions as fundamental axioms.
Where? It says...
At 47 after the hour, M. Scott Veach, Quantum Physics Explains Newton's Laws of Motion. Newton was obliged to give his laws of motion as fundamental axioms. What are the odds of that? Sometimes they just, even the universe didn't want to let you do this.
All right.
Come on, guys.
Look.
Come on.
What Scott posted, though, if you read the rest of what it says, it doesn't say... It's the same thing as when Riley used to post that one thing about breaking the 1 and 2 or whatever. It's not saying that it's that these things are not applicable or they don't work anymore or whatever. It's just saying that the more fundamental rule is the quantum principles, and they bring about these 3 laws.
No, that's not what... Dude, you're just... What do you... Bro, you just made that up.
It basically says that. It says it's fundamental. Yeah. The fundamental groundwork is the fundamental... These are just consequences of the fundamental quantum laws.
Yeah. It's self-evident.
Okay, so Newtonian physics doesn't work on the quantum scale.
It says they derive classical mechanics.
Yeah, exactly. So it kind of says the opposite of that. It says that it provides a foundation for it. I actually think...
How does it provide the foundation for something that predated it?
Hold on, can I just... I think what is a better way to say it, maybe, and tell me if you guys would be on board with this, is that it's not that quantum mechanics violates the 3 laws. It's that they don't really apply. This one has an echo. It's really bad. It says the 3 laws aren't applicable in those conditions. There aren't situations in which
that's what I said. It doesn't apply on the quantum level.
Yeah, but not that it violates it. Just that it doesn't really lend itself to being.
My original premise is that it doesn't apply on the quantum level, so it can't be a natural law.
Well, no, it can be a natural law because it doesn't apply to love either. You know what I mean? Not applying to
love isn't natural.
Sure it is. What do you mean?
Love is a concept that isn't in the natural world.
It does. My point is that it doesn't have to apply to everything, right? Just think.
Okay,
chill. Just talk like a normal adult and just listen to ideas.
You can't say it's the foundation of it if Newtonian physics...
Stop interrupting. Just because an idea sounds strange to you at first, there's no reason to interrupt and throw a fit. Like, just work with each other. So just because the laws don't apply to everything doesn't mean they're not laws. In situations in which they apply, they self-determine, right? Like, for example, it says if a mass is moving or a mass is not moving, then we know something. But if you're not dealing with a mass moving or not moving, then it's not applies.
What about quantum locking?
What is quantum locking?
Okay, so can we move on?
I thought we talked about it earlier today. Did you ever come up with an answer? Because no one had heard of it.
Quantum locking, dude.
No one's heard of it. The whole room had heard of it.
Levitating in an object using electromagnetic forces.
My goodness, everyone knows that.
I think the main point, Scott. The main point, Scott Beach. The main point I think is that you need to, when you're working, it's a completely different regime you're working in if you're considering anything quantum mechanically, where particle
gone from enormous to.
Was he not just talking, dude?
Particles and objects are described as a superposition of the wave function. So it's just a completely different working regime. Right. Like
gravity is no longer a thing.
No, I know, but I'm just saying it can't be a consistent natural law. It doesn't work on all scales. Same thing with general relativity.
Right. It can be a consistent natural law as long as it isn't violated. To violate it, you have to have a situation where a mass
doesn't apply on all scales, my friend.
Hang on, Scott. If he can marry classical physics with quantum physics and the general theory of relativity, there's a fucking Nobel Prize for whoever can fucking do that.
That's a fool's errand.
WITSIT, because it doesn't hold in all scales does not nullify the entire thing.
No, I didn't say that, man.
That was my point.
I said it nullifies the Newtonian physics framework, not necessarily some of the axioms within. There could be more information within the limited understanding of what we claim the axioms are, maybe. But they can't be natural laws because they don't apply on all scales.
Well, Thomas Kuhn in his book on the...
When you look at natural laws, they always say, hey, assuming that all mass is a certain point and things like that, right? All of these natural laws have assumptions in it. They're not supposed to apply to quantum physics.
That's true, and Newtonian is built off of bumping particles that transfer their energy. But the thing is, Newtonian does work for engineering and for large-scale applications. So people kind of still use it in physics and stuff. But at the quantum scale, they're not observing this stuff, so they have a bit of a problem. Both of them could possibly be true, but they're trying to find a way to link the two, if at all, subsume one under the other. Probably quantum mechanics, because they're trying to find the part of it, trying to find the thing that makes the universe tick.
Thank you, Slacker.
So, just because something in physics doesn't scale doesn't mean it's not valid. Hydrodynamics doesn't scale, and no one's arguing that it's fake, are they?
It's applicable within the confinement. It's relevant.
I'm sure there's a great analogy.
Same for Newton's laws.
Okay, but it's not a natural law about the world because it doesn't actually apply on all scales, though.
It doesn't have to apply on all scales.
You said, dude, if you can tie... Listen, he said if you can tie Newtonian and Einsteinian physics all together with a quantum scale, then you'll have a Nobel Prize. That's a fool's errand. It's a futile pursuit, dude, because they hold contradictory conceptual backings.
That's fine, but let me tell you why it doesn't apply. And the reason it doesn't apply is because it's to be violated. That's when you would really have a problem. To be violated, we'd have to find an example of something that is accelerating with no force, or is it is staying in stasis with a force. A force is acting on it and it's not moving at all. Without an example of that, without a counterexample to the law, then we're not violating it. So it just means the embedded in this law, the first law, for example.
Why do you keep saying violating? That's a straw man.
I don't think it is because it's.
Well, I clarified that it doesn't apply because you're getting semantical. I've already clarified this point twice.
But so not applying is okay because embedded in the law is the situation.
Well, it doesn't apply on the quantum scale, so it's not a natural law. Okay. You can't say it is.
It is a natural law.
You know what's required for it to be a quantum? Do you know? Do you even know what's required to make it?
It's my last sentence. It doesn't need to apply to everything because it tells you when it applies, and as long as it's always true, then it's a law.
And what's required then? What would be something that we would have to be?
Hold on. It says only invoke me when the mass is either not moving or moving, and that's when we invoke it, and that's when we check to see if it's true.
What is something that would have to be required to be found to even begin to try to fix the fact that it doesn't apply on the quantum scale? Do you know?
Quantum loop gravity.
Graviton.
Quantum loop gravity.
Graviton.
Okay, if you want it,
need to apply on the quantum level.
Yeah,
Graviton.
but Scott, if
You
he
have to
wants to
find the
get into
graviton.
this, if he wants to get into this, he needs
You need to
start
find the
looking into-
graviton.
You guys are missing the point, I think.
No, that is the
Yeah.
point.
Hang on.
You guys are talking about something different. You're talking about a unifying theory.
I was trying to say something.
The gravitron is a theoretical
Guys,
particle.
yeah, stop bringing up stuff that's not important, dude. No,
It is important because it's
quantum loop theory. That stuff's not relevant here.
It is. It is relevant.
The thing that he posted, the thing he posted said it clearly. It said that what's the word that it used? It said that it leads to the principle. It derives the principles of Newtonian mechanics. Okay, and so that exactly what he's saying right now is that it does. It's not a contradiction because it doesn't apply in some places. It's a subset of the rule that encompasses it all, which they're claiming.
Do you even know what that means? Do you even know you don't even know what it means then? When he says derived, what does it mean when it says derived?
It means that this is the fundamental, and that from this, the fundamental laws are derived the laws that we already know.
Right. So that means that they're incomplete then, right?
It doesn't mean that they're replaced. It doesn't mean that they're contradicted.
No, they're incomplete.
They're not the fundamental laws. The fundamental laws are something greater, and they derive these other laws.
Yeah, they're incomplete.
Yeah, I mean, honestly, dude, I think Gary posted something that made sense a second ago.
Wait, Coach, do you agree that they're incomplete?
All of these laws that we talk about, they have limits to when they actually are true or not. And those are disclosed very, very.
All right, man.
Okay. Slacker brought up a perfect example of hydrodynamics. I think he brought up is hydrodynamics. And there's certain principles and laws that are applying in certain scales and certain regimes, but aren't contradictory to other laws that apply in other places, but they're not the over-encompassing laws.
At what scale do hydrodynamics no longer apply?
Well, even more than no longer applying, it applies differently at every scale. You can't scale up water and have it behave the same.
But we know how it behaves at every part of the scale, right?
Why would you expect hydrodynamics to actually apply when we're talking about
hydrodynamics? Well, someone else brought that up.
Yeah, it was an example of something else.
But it wasn't. I just pointed out why it wasn't.
You say, why would you expect?
Literally, it's literally non sequitur. You know,
something that actually affects how a molecule of water reacts to a molecule of something else.
Guys, I researched this, dude. The only way you could ever try to fix the problem, you got to find the graviton first. I looked it up. You got to find the graviton first.
That's an assumption, and it says there's no.
It's just a theory. It's just a theory.
It's not even a theory.
Okay.
It's merely a hypothesis.
Well, no, but if gravity is what we think it is, and it is on the quantum scale, then the graviton has to be somewhere. It's just really hard to find it.
That's an assumption.
No, I know that. I know that. Trust me. I know it's an assumption, man. That's what I'm saying, though.
It's not a theory. It's just an idea that people.
Dude, no, you're right. You're right. Okay, it's not a scientific theory. I was using the word theory colloquially, bro. Okay, so chill, man. It's not a scientific theory.
Are you there, Kosho?
I was talking 10 seconds ago, dude. Just get
it. I'm just making sure. Have you heard of the quantum loop gravity that they are starting to research, right?
It's another theory that they're just starting to research, right? Which again is not some proven idea. It's another idea for what might be.
Yeah, but at least trying.
Right. The only reason I brought it up, dude, was just to point out, like, that gap has to be bridged. And of course, you'll never find the graviton, in case anyone's wondering. I mean, you'll never find anything like that. So you need to just let it go. We're a little bit off at the least. We have got to update.
That's just as
quantum mechanics is the one branch that is the least acknowledging this.
That is just as silly as saying that there is a graviton and saying that there isn't one. Because what the true answer is that these are things that people are investigating. A lot of people, smarter than all of us in this room, are investigating, and we'll eventually have answers that could add on to the two theories that we're talking about, quantum field theory and general relativity, or it might adapt them, or it might transform them. It could be all sorts of conclusions that we don't have any idea of what it's going to be. So,
well, my opinion is it'll never be found. Is that better phrased?
They're not smarter than me, man. They're not smarter than me. Speak for yourself. You said they're smarter than us. They're not smarter than me. Give me blood.
But yeah, at least quantum. Like, I respect quantum mechanics for at least having like the structural cojones to go against the establishment, if you will.
So that's kind of is the establishment.
Yeah, exactly. Yeah. Now, because it's taken over, like kicked out the bullshit in a way. Well, at least it's like experimentally valid. Like, the explanations, that's a totally different conversation, but like the experimental value of the results that have come from quantum mechanics are very, very valuable. And that's more like what we should be doing in every single one of these areas that we discuss.
You mean like we've done with relativity and other?
No, general relativity is bunk. It's bunk on its face.
Except there's been so much evidence proving it.
No, it's a mathematical construct, but the math is off by 10 to 120th power.
That's not the same.
It's incredibly accurate above the quantum scale, and it's been experimentally validated.
The layout of space is off by 10 to 120th power because general relativity.
It's not. They're comparing two ideas, one from each.
Okay.
The 0 point energy, or the vacuum energy, and they're comparing what's the other one? Is the cosmological.
Oh, the one that we all know is there, right?
Oh, they're comparing these. It's two ideas from that each of these are incompatible for that reason.
But why did we come up with dark matter then?
You guys are skipping a level, right?
There's a cosmological constant. That's why we came up with dark matter.
To make up for the show.
Before you start comparing quantum level to, if you want, just general physics, let's start comparing general physics to the molecular level. Then from molecular level, then you go to quantum level. Right? You guys are skipping the whole.
We're going to continue the conversation.
Right? So there's a big difference. And it seems like you guys are never going to.
The cosmological constant is why we have dark matter, right?
No, Scott Veach, please talk.
Go ahead. I was just going to say something that Slacker said that I always think is fascinating, which is that the amount of times in which we've experimentally validated relativity is so huge. But then sometimes I'll read about these experiments, and it really is mind-blowing what kinds of things it's predicted that have turned out to be spot on. And like a classic example of this is that, these predictions about how taking an atomic clock and traveling, causing it to travel at high enough speeds on a fighter plane or a bomber, and then re-landing it and then comparing it against a atomic clock that didn't do that speed, and seeing the differential that's predicted perfectly by these equations. I mean, it really does kind of blow your mind to think, how in the world did this theory that Einstein has in 1919 or whatever, how that's going to eventually predict in 74 this kind of experiment to the degree of precision that we're able to predict? It just seems
to equate
to do that and not be true.
Bro, to equate a physical mechanism measuring oscillation rate of cesium atoms with the concept of time is laughably incompetent, dude. The problem here is that this is the truth about it. General relativity is a mathematical construct. It didn't just like come out of nowhere. The foundations for general relativity's mathematical aspects were already in existence. There was a conceptual backing that was introduced with it. When you extend it past the local scale, it doesn't work because of what he brought up, a cosmological constant. We have dark matter because the galaxy rotational speeds don't match.
Okay, that's what I'm saying. You said this earlier.
You're not really explaining what you said though. When these experiments are done with these atomic clocks and they conform and confirm what Einstein said, isn't that amazing?
Well, no, not whenever you're just looking at oscillations rate. The differential's laughable. You don't account for pressure differential, for vibrations of the plane,
but it's predicting perfectly. Whatever it accounts for is predicting it perfectly or close to perfectly.
No, it's not.
And it's not the kind of thing. Yeah.
What's the p-value?
So when I don't know what the p-value is, but when they come back,
how do you know it's predicted perfectly?
Because I've read about the experiments.
You have to know the p-value.
Whether these are value. I don't know all the details. I couldn't even tell you what the actual error was. But when they compare the atomic clock differences, they are predicted by the equations.
He said he couldn't tell you what the error is, but it's perfect. That's what you're saying.
Because I read the conclusionary statements. And I believe the conclusionary reports that I read. I'm trusting these conclusionary reports.
Feel free to cite it with the p-value.
Okay, but let's put aside this distrust of anything we ever read.
No, the trust comes in knowing the probability of outcome.
It's just obstructionist of you. Instead of actually talking about the issue now, you're talking about like, well, you can't trust everything you read.
What's the probability of outcome?
Hold on. Let's just pretend that what they said is true. And then you have to imagine, how in the world are you going to predict an atomic clock being off by precision of, say, I don't know, 100th of a nanosecond? How are you going to predict that? And what direction you predict that on your own? You're not going to be able to do it. It's only through the equations of relativity that you're able to do it.
What if you only got that rate? What if you only got
the fact that they successfully do that is shocking. It's shocking.
I'm not logging, Scott.
Dude, what if you only got that reading one time out of every 100?
I'm not monologuing. When WITSIT is interrupting every other sentence,
that's not true.
I have to start over to get. See, don't ever accuse me of monologuing, but I do just sometimes. But wait until I actually do it, because this is not it, dude. And that was a dick thing to say.
What is the p-value?
Kosho,
you monologued right past the p-value.
I don't know those details.
So you don't even know what the probability of outcome is. What if they did it 100 times and then it's supposedly confirmed GR one time?
Can I please give him the answer? Jesus fucking Christ!
Thank you.
I sent you guys an article. I can send you the scientific papers that back up this article. Unlike the thing about the fruity water earlier that you couldn't provide. What's it? But the experiment confirmed Einstein's prediction to within 140 parts per million.
That's not the p-value.
That's the accuracy of the measurement.
That's the error. That's the error window.
Accuracy of
right.
The measurement.
But what's the p-value?
Do you understand what he said?
No, I want to know what the p-value is.
It doesn't matter what the fucking p-value is. What I realized.
No, you're just you're just incompetent.
He just told you how.
Kosho's incompetent. And
close. Dude, shut the fuck up.
Stop doing that. Just be mature, dude.
Well, did not let me ever actually explain my point while y'all strawman it.
You get tons of free time.
P-value.
Okay, so can I actually explain my point or not? So the p-value is independent of that, because if you got within to that close of a prediction one time out of 1,000, your p-value would be very low. Bruh, your p-value isn't how close you get to the prediction. It's how many times you get that close.
That's not what it means.
Oh my god, dude.
That's not what it means.
What's it? I understand, but it's not relevant in these observations. In this context, it's not relevant.
Why are you saying? Because just the fact it could get that close one time proves it?
Because the observations, the number of events. So first of all, these were not independent. These were not independent identically independent measurements. They were not random events. They were thousands of repeated measurements over the course of this experiment. Thousands of the same
measurement 4 or 5 times, years and years apart. Why
are y'all interrupting him?
Plans. I'm just adding to it. Done different times, 4 or 5 different times.
So the most relevant
planes every time.
So the most relevant, one of the most relevant metrics to describe how accurate this measurement is the parts per million, or the error, like you were saying, the noise or the error in the overall measure in their results, which is 140 parts per million, which is incredibly accurate.
Right, because that's a very small differential. But how many times did we get that close to the predicted value, though? That's very, very important if you're touting the predictability of GR with this postulation. Then the predictability rate is inherently important. So it got twice out of how many times?
At least twice. I know twice just off the top of my head.
Where they got to within that value twice?
Yes, they got within that value. They have one. That's the original value.
Out of thousands of times, they got to within the value twice.
Listen, WITSIT, you're doing the interruption thing again. That's the original thing. There's the heating Kepling experiments in the 70s. And then just recently they did another version of it with an accelerator and got it more precision. Got a better
it's not result. The precision that's in contention, Scott.
I thought it was the precision. You just asked that.
No, it's the p-value.
No, we weren't talking about p-value.
I wasn't talking about the p-value. That's crazy. I was going to swear.
You don't even know what it means, man.
It's the probability of outcome.
No, it's not.
So you just say, nuh-uh. That's your response?
Well, I posted what it is. You can look at it.
So the p-value isn't the probability of outcome? Is that your claim?
Yes.
Probably.
Okay, what is it then?
I posted it already.
Well, just tell me what it is then.
I choose not to.
If I'm wrong, then just say what it is.
No, you don't know what it is.
He's afraid to say it because he knows I'm right.
When you say probability of outcome, what are you trying to say? What probability of what outcome?
Yeah, it's the value you get out of how many times you got the expected results. The success rate, the probability of outcome, the chances, the amount of times you got that result, the probability.
No.
That's not what it is.
Okay, so what is it then?
You're kind of close, though. Here's what it actually is.
All I have is pedantic, semantical bullshit.
Well, if you would stop interrupting, you'll hear the actual answer. What it actually is the probability that the results you got would have been gotten by random means. So it's a probability that what you're seeing as your experimental results could be just random luck.
So I said probability of outcome. You said the probability that you got, but I was wrong.
Yeah, well, actually, what do you mean by outcome? What did say after that? The probability of success, and that's not what it is.
I said probability of outcome.
Just said probability, dude.
And then I asked, what do you mean by outcome? And you said the probability of success.
Can we just move on from the semantical diversion attempt, please?
Well, I think it matters, dude. I don't know why
you think
so
it matters because you just want to try to find some way you think I slipped up. We actually acknowledge the premise.
I could care.
What's the p-value?
You so much, I could care less about that.
Well, now that we've defined what the p-value is, what is the p-value?
It wouldn't apply in this case.
So do we not have to? Okay, can we at least get like a percentage of the amount of times we got the expected fucking result? Then
it's so stupid, though.
Is that an unfounded request? Is that what y'all think?
Not always applicable. Like we were talking yesterday with Chronic about about predicting a supernova using Einstein's equations and gravitational lensing, and predicting it when it was going to occur, which is not something that is. Not something that
it can't be done. It can't be done normally. Yeah.
You just predict when a supernova is going to occur in the sky. But it
was, that's a fairy tale.
Using Einstein's equations and gravitational lensing. And
and then you know how much a teaspoon of it weighs somehow. But anyway.
Yeah, those neuron stars.
Yeah.
Whatever those are.
Yeah, those damn things, those damn fairy tales Jesuits came up with.
When was the last supernova we predicted, Culture?
That was the only one that.
No, the only one ever in human history. A supernova was predicted to occur at a specific location in a galaxy, and then it happened.
Okay.
And then the prediction became.
How many have been predicted?
But with those kind of predictions,
how many predictions have we made?
We've made.
How far was the prediction of?
We've made one successful prediction.
But how many predictions did we make overall?
We've made one.
One accurate prediction, but I mean, how many attempted predictions?
What are you even asking?
Yeah, because they obviously had to keep on trying to predict the supernova, right?
If they predicted a million supernovas,
they literally submitted a proposal to use the Hubble telescope based on their prediction, and guess what? Their proposal was accepted.
You mean the Sophia?
Yeah, the one that's in the airplane. Yeah, exactly.
They say that. No, NASA says that Sophia can take the same pictures as the Hubble telescope.
Not quite what they say.
No, that is what they say.
There's no way it can. Sophia is like 200. The difference of height between the both of them means they can't take the same picture.
Have you ever researched this?
Yes, we all have.
Yeah.
It's not really.
They have it has the same capabilities as the Hubble telescope.
Sure.
But there's a lot more. There's a lot more.
Yeah, it's different because of its location. Y'all are once again looking for semantical diversion.
No, we're telling you they made a prediction. They said when something was going to occur, and it occurred then. There's no p.
Wait, but what? What?
It's not relevant in this situation.
I didn't say p-value back to that, dude. Because that
when those things are not needed.
What's it?
Okay. Every time general relativity comes in, the p-value doesn't matter.
What's it? There was a there was a phenomenon that was observed in the sky, in space, happening in a galaxy. A star went supernova.
It was predicted.
No, let me finish.
Sorry.
Okay, this supernova was observed, and the galaxy that the supernova occurred in was multiply lensed by a foreground massive galaxy cluster. So it was lensed into multiple different images. Okay, we observed the supernova. So it's just a bright point, a bright star in that galaxy.
Of course.
So that supernova itself was lensed 4 times. So we saw 4 different images of the same star, the same supernova star. Right. We also saw multiple separate lensed images of the galaxy that the supernova occurred in. There were 3 separate images of this galaxy that were lensed by the foreground gravity, of this cluster in between. One of the based on Einstein's relativity and the light and the time it takes the light to travel and bend around, follow the curvature of space-time, the scientists predicted. So in this other lensed the other image of the galaxy, there was no supernova that was observed. There wasn't a bright point of light in this other in the identical image of the galaxy that was lensed. So the scientists predicted that the reason they didn't see the supernova in this other lensed galaxy is because the light had not made it to Earth yet. The light from the supernova, because it's been lensed and bent in all these, funky ways, had not yet reached Earth. But using Einstein's equations and the lens equations for gravitational lensing, the scientists predicted a time in the future, like a year in the future, roughly, I don't know exactly, maybe a year and like a month or something, that they predicted we should see this supernova go off in this additional lensed image that was created. So they wrote up a proposal, they submitted it to to the committees that reviewed it. They got their proposal accepted. They used Hubble to take these images over the course of like 6 days, and lo and behold, they were off by a day. By like a day, they were off. The prediction wasn't perfect, but during the course of their 6 days of observing, one day after the other, they caught the supernova going off in this extra lensed galaxy. Perfectly predicted.
No. Hold on. You just said they got it off. It was off for one day.
Near perfect prediction.
Why is that perfect prediction?
All right, you're gonna call out semantics.
Okay, but don't do what they do. Don't do semantics. I hear what you're saying, but please, because that's what they do, and that's what I'll take attention with.
Near perfect prediction.
Okay. Here's the deal. How far away was that galaxy? Just say really far. Just really far, right?
I think it was 9. They said it was 9 billion.
Sure.
Okay, so do we agree that relativity doesn't adequately predict like orbital trajectories that far away?
I don't agree to that whatsoever.
But the galaxy rotational speed shows that the assumption of the speed of light could be off drastically as early as
you're using an absolutely irrelevant moot argument to introduce
I'm trying to make sure. I'm just trying to get foundation here. So you're saying that I'm trying to understand. I'm genuinely trying to understand. So general relativity is at least got some accuracy on the very large scale, then, right?
Of course it does. Of course.
It just isn't entirely accurate.
On the I would say on the universal scale.
So what did the people that made this prediction think that the odds of their prediction being correct were pretty low?
No, they thought they were pretty high. That's why do you think their proposal was accepted? If their odds were low, if this prediction was crap and they were just making it up, you think that these committees
they weren't making it up, dude. It was based on general relativity.
And their predictions made logical sense. So the review committees.
I get it. Yeah, of course. I heard that part.
They were like, "Oh, wow, this makes sense. This would be a really cool observation to make. The first in history, the first of its kind ever. Someone predicting a supernova before it happens. Let's give them the time. Let's accept their proposal and let them use Hubble." And they did.
That means general relativity is adequately predicting the light travel duration.
Yes, it is.
We've been talking about this prediction for a while. Can somebody please explain how they predict?
Can someone link it? Kosho, could you link the...
No, can someone just explain really quickly how we were able to predict.
Okay, Branch.
Explained it, man.
Branch. It would take. There's no.
I just got back
Branch.
taking the piss.
Branch. It's impossible. So your request is impossible.
It's
impossible to quickly explain all the intricacies.
There's the gist of it.
Did you not understand? How did you not understand the gist of it? He just explained the gist of it.
He
was gone.
Oh, okay. Sorry, I missed that part.
It was lensed.
Yeah, it was lensed.
Yeah, using GR and then gravitational lensing, they could predict it out. They got 1 day away from a prediction, a year and 4 months out.
Because the lensing doesn't only transmute the same image, like the Einstein ring, like in a circle around the other object. It also has time.
It causes the distance. It causes the yes. Sorry, Kosho, to cut you off.
I was going to say that the time dilation also it causes.
Yes.
So you'll see it at different times. You're actually viewing the same object at different times, and they used Einstein's equations to predict exactly how the time dilation is going to be is going to influence when they're going to see the supernova in one of the other images that was superimposed. So there was like 4 different images of this thing, and they predicted when it was going to occur on one of them, only using the information about the galaxy, like the mass and all that kind of stuff.
Well, I mean,
Okay, but what if everything is smaller and more local, dude? Have you
that-
considered that, honestly?
So, Kosho, hold on a second, dude. So, Kosho, basically what I'm trying to say is the gist of it is they were able to predict the supernova because of time dilations.
Basically.
But listen,
yeah, and I heard your question was that's the point of what we're making. In order for them to make these predictions correctly, the information, and that's probably why they were off by a day, perhaps. Maybe something slightly different about the mass was slightly off or something like that.
It's just error bars.
Yeah, exactly. But the exact, like, the values of these things have to still be within some sort of accuracy for them to be able to make it.
Right. I agree. Unless they are smaller and more local.
If
that
you have-
way,
Go ahead.
What?
Yep. If they're
Well,
smaller,
then-
local, yep.
right. So then that could be scaled down to the same proportionate values.
Do you have any empirical evidence that backs that claim whatsoever?
Yeah, that you could scale things down proportionately.
No. Do you have any empirical observational evidence whatsoever that backs up that claim at all in the history of the universe ever?
That the sky could actually be closer and more local.
Exactly. Yes. Exactly.
So yeah.
Anyway,
like all
what's
the
really-
observations ever.
Yeah. Sure. Gotcha.
For example, like you can't see part of the sky from a certain location on Earth. It's relative to your location based on how far you can see.
This is your expertise, Kronks. I think it's better to answer how it can't be, how the mass and the time dilation, all that kind of stuff, how it can only be predicted. How that lensing can only occur with a mass that size. Like if it were a smaller mass, you would not get that type of lensing.
What if it was smaller and closer?
And that's why.
Gravitational lensing. You're right. I agree. Just to save some time. Of course, if it's smaller and closer, you can't use general relativity with it being smaller and closer. That's not what I'm saying.
Mm-hmm.
Of course you can't do that, dude. I'm just saying your interpretation of the data based upon the application of general relativity and assuming distance and mass could be wrong scaled down. Without GR, you could predict similar reoccurring events or
it's just more
relationships.
Yeah.
Well, okay, I'm sorry, that's all general relativity is though.
No. There's a mountain of empirical observations and evidence.
No, the observations happen first, dude.
Consistent with the theory. No, not at all. Not at all. The formalisms and the phenomenon has existed for eternity. Einstein did not invent any of this, just with Newton and Newtonian laws and anything.
Lorentz transformations.
None of these scientists invented any of this. This is all these fundamental laws.
Einstein's compiled everyone else's work.
They've existed for eternity. These scientists, their claim to fame is that they were able to formulate them into equations and math constructs that describe what we observe and empirically measure, with very high consistency.
And it was a trial and error process, right?
What was?
Yeah,
getting the mathematical accuracy to where we supposedly have it now. I mean, it was a whole ass process.
No,
objectively it was.
No. So the formalism.
Then why do we have to introduce Lorentz transformations?
No, you're scattergunning or tangent. You're off on a tangent. So Einstein. Oh, Kosho posted the good video about it. So Einstein developed this formalism and these ideas and first principles, like equations, and predicted that the deflection, there would be an observed and measurable deflection of starlight next to total solar eclipse, which Arthur Eddington and other people took data on and empirically validated. So anyway, I before we get too far from it, one more last really cool thing about the this first ever prediction of a supernova. They worked out so like I said, there were more than just one lensed image. There were multiple, like 2 or 3. So what's really cool is they actually worked out the math with Einstein's equations and the lens equations for gravitational lensing to figure out that the supernova was going to occur a year in the future in one of the lensed galaxies, but also the supernova already occurred like 16 years prior in the third lensed galaxy. It already occurred in the past.
But we have Newtonian physics and Kepler's laws, and then Lorentz transformation absorption into the Michelson-Galilee, Michelson-Morley experiments, which they now ignore Michelson-Galilee and Michelson-Morley tangent together because they disprove heliocentrism, which is why we introduced relativity in the first place. So then we had to create the Lorentz contraction, which is where it says the apparatus itself in the Michelson-Morley is actually contracting. That is a mathematical construct from Lorentz transformations. Okay. Newtonian physics has a foundation in it as well. Like you said, he compiled all this. They were all reverse engineered based off the reoccurring phenomena of the solar system on a local scale.
Not true.
Yes, it is true.
A prediction by...
How did we come up with Kepler's laws without looking at the solar system, dude?
He came up with them.
By looking at the solar system, right?
By looking at
the lights in the sky, assuming the relative nature of sphericity.
And that's a completely different theory. As I was trying to say a second ago, one thing that relativity predicted that branch.
Branch, let's eventually say
give me a minute,
okay? Please.
Go ahead, Slack.
One neat thing that relativity predicted that was completely new it wasn't based off any observations. It wasn't, as far as I understand it, there wasn't anything like it in any other competing theory, was frame dragging. That not just mass deformed space-time like the example that we've all seen with the bent sheet, but a rotating mass actually drags space-time along with it and twists it. That was a new prediction, and it had never been observed until 2007.
No, it's still never been observed.
Well, you can disbelieve it, but...
Wait, the curving of space-time has been observed?
I'm not talking about the curving of space-time. I'm talking about the twisting of it by a rotating
the twisting of space-time has been observed?
Yes, it was measured with the Gravity Probe B mission.
It wasn't observed.
Yeah, this warping of space-time was one of the first things that was observed.
No, space-time wasn't observed doing shit.
Well, the light.
We observed the light following.
Yeah, right. We understand the trajectories and we map them out in the space-time fabric based on gravity wells of the land layout of the mass, or the layout of the mass. How do you explain
seeing an object four times at the same time? Like you see it in 4 places at the same time.
See an object 4 places at the same time.
Yeah,
that's so the perception of what we see in the sky proves that concepts bend and warp.
No, that's what you just said. So space-time being warped is what you're seeing.
No, you're seeing a fluctuation in perception.
He doesn't have an answer.
I just answered it.
That's not logical whatsoever.
How is it not? You have to understand what medium you're looking at the lights through, right? What if your medium assumption's wrong? Dude, it's not even complicated.
Another what if.
No, it's a what if that's acknowledged by the top proponents of your model.
Come on, man.
So you're saying that the top proponents of the heliocentric model don't acknowledge the what if the medium assumption could be wrong?
You know how many times Hubble has observed gravitational lensing? Hundreds and hundreds and hundreds.
You're presupposing that's what it is.
Come on.
You just presuppose your
God, listen to
causation
yourself.
over and over.
Dude,
Experiment tested if there was
it's like it's like repeating it over and over again.
No one can acknowledge if the medium is different. Would it change it?
WITSIT, stop over talking, everybody.
Yeah, the same prediction that was first made to substantiate him after the fucking Mercury thing was the Eddington experiment, Eddington observation. I mean, when he made this observation and he's predicting what it's going to be 6 months beforehand of where they should be, depending on if Einstein's equations are true or not. The fact that they turned up to be exactly where they were predicted to be is not something like, unless some freak coincidence of the world, there's some mechanism nobody knows about that happens to give the same result of the same thing that you were looking at, depending on if these other mechanisms or if these other ideas were true. There's no way to, there's just no way to, I don't know.
What if your medium assumption's wrong, though?
But this is, isn't this the...
With a medium that's going to come with those same results.
Yeah, fluid-like, more material, 1,000 times more dense medium.
But these are the P values which you're talking about, right?
The same effect as the thing that you're predicting.
No, it's not. Wait, what?
What are the odds that that thing that you just said that you just made up is going to have the same effect as the thing that you've been theorizing?
You do know that I could take the same math that predated general relativity, and it already predated it with the material postulation of a background. The math wouldn't change. Do you not know that?
Make a prediction, a novel prediction that no one's ever seen.
Yeah, because it's using the math, and the math wouldn't change.
Go for it. You go for it. Don't give me any money. You get the prize for that, but go ahead and do that.
Okay, see, now you're saying, yeah, I'll have to take the math that we can all use, and I'll have to come up with something before someone else does to way to use the math, because the math is accurate based on certain relative or certain relationships, and then I have to pick something else like random as fuck. But nevertheless, my point is you can change the conceptual backing and use the same math. The math was used to make the predictions, so the medium assumption could be wrong, and you could still use the new medium assumption or interpretation with the math to make the same predictions. The predictions were made with the math.
Good luck.
Not
Good luck to do that.
Before it actually occurs. Before this novel thing occurs.
Okay.
You have this insight to know when it's going to happen based on you doing exactly what you said.
Well, you are okay, but the general relativity conceptual part had nothing to do with the prediction.
It absolutely did.
No, it didn't.
I think that the light was going to be in a different position.
Because of the calculations.
No, because of the mass and the size of the mass and what the mass.
Oh, so those aren't calculations?
That went into the calculation, indeed.
Mass isn't a calculation?
Mass goes into the calculation.
Right, so based on the calculations, you can determine when it should get here. The math isn't in contention. The math pre-existed Einstein.
That did not pre-exist. What existed beforehand was...
Wait, what math did Einstein come up with himself?
The warping of space-time?
The math.
What he used beforehand was, what's his name? That one guy, the German dude is his name. The guy who came up with space-time. He used his constructs of space-time, and he used a couple other equations. So yeah, man.
What math did he come up with on his own?
Why does it matter? Why does it matter if he used other people's math?
Well, my point is that because the math is what was used to make the prediction, it has nothing to do with the conceptual backing that general relativity is.
Well, Einstein formulated. He formulated the field equations that are used to predict. The field equations that are used for general relativity.
So you're saying Einstein came up with the field equations?
Well, they are called Einstein's field equations.
Okay, but what did he change from the pre-existing equations?
He only used the conception of space-time. Yeah.
The Minkowski space-time and all that.
Wait, what?
He had a colleague back in the day named Hermann, or some German guy named last name Minkowski.
And he took his math.
They collaborated together on...
Right, he took everyone's math. That's all he did the whole time.
It was his teacher at one point.
Dude, he actually failed the competency for mathematical engineer, like the mathematical competency test for engineering school. So I don't know why we tied him up. No, you know why he got a Nobel Prize? Because his first wife was Siberian and very, very efficient mathematician. Well, she wasn't?
His first Nobel Prize was to do with experiments with the what do you call that? With
yeah, who co-authored what got his first Nobel Prize? His wife.
yeah, she helped him write. She helped him write some of his papers.
Yeah, she was a Siberian mathematician. He wasn't very good at math.
Yeah, the photoelectric effect is more to do with the experiments that other people had done, and that he had also been aware of, and the ideas around that. It's not the stuff. She probably helped him with a lot of his papers. That is true. That she helped him write a lot of his papers. But
and the math in it, because he's touted his genius is in the fact that he supposedly had this abstract comprehension of such a profound idea that he was able to provide the conceptual backing that was missing. The mathematical components he had nothing to do with. There's a natural efficacy or of mathematical deduction. He did not have that quality, dude.
No, he used other ideas, other people's math that they came up with, probably his wife's writing. You know who else used their wife's writing? I think Niels Bohr. Also, he couldn't write at all.
Well, I'm not saying this invalidates everything he ever said.
That's not. You were right what you said. His great the great thing that he did was put these things together and come up with these thought experiments and these ideas that were novel to him. I mean, those things that is the incredible addition that he had to. You're right. The math in some places existed already. And
in fact, when you look a little deeper, really what he did was he pieced everybody's stuff together. Like even his conceptual part, and I'm not even taking away from him. He pieced it together. That's it. That's why I used to have him up on my wall. I used to have a poster of him, right? But what I'm saying is, like, the conceptual backing is all he postulated. The math itself is what's used to make predictions, like what he was bringing up. So that's the medium assumption is important, man.
Can I just ask? I gotta go to bed. I want to ask WITSIT real quick. Do you know do you know what the Jesuit priests, Nobel committee? Do you know who they awarded the Nobel Prize in Physics this year to?
I don't know. Probably some graveler.
Yeah, exactly. They awarded it. So they awarded it to share between theoretical astrophysicists and observational astrophysicists. So half of the prize went to Roger Penrose, and it would have went to Stephen Hawking if he didn't die, for their theoretical work that showed that black holes are a robust prediction of Einstein's relativity, and the other half of the prize was given to observational scientists who use telescopes to observe a supermassive compact object at the center of our galaxy. That stars are whizzing around very, very close.
Utilizing the mathematical deduction, man.
Good.
That's all it uses. The math.
That's impressive, though. All those dudes I like, man. I like Hawking's. I like Penrose. Einstein's dead.
That's interesting. It's definitely interesting.
Honoring him.
But when you say general relativity, I mean, general relativity made the claim. Well, not the conceptual backing of general relativity. Space-time bending. That concept part that we used to try to explain the fucking math, that didn't make the predictions. The math did. That's all I'm saying, bro. The medium assumption's wrong. I can tell you that, man. The medium assumption's wrong. That's my opinion, and I'm quite definitive in it.
But you can't substantiate it whatsoever.
Well, the fact that galaxy rotational speeds are so far off actually works in my favor.
It's just a what if that has no.
No, it's not a what if. Objectively, we're way off because of the galaxy rotation speeds, and that works in my favor. Because if there's solidity and more rigidity, and there's a background of density, then it's going to work in my favor.
To help you out, man, because you said this earlier in a very long sentence, but the sentence included both the discrepancy between the 10 to the 120th power thing, and you're really talking about the cosmological constant, and these things aren't related to the rotational speed of galaxies. As you said earlier, dark matter. No, dark matter has to do with that dark matter is actually the name of that problem, of that issue with the rotation.
Yes, you're right.
It's not said that it's matter. It's in they don't know if it's dark, but they are assuming, so that's why that name is there. But it really just means I don't know what's going on.
It means we don't know what's going on. We are assuming it's material.
Yes, the cosmological constant is something different, and that is related to dark energy,
which is a byproduct of dark matter.
No, there's no reason to think that
it's not derivative of dark matter.
No, not at all.
So one can exist without the other.
We don't know.
Well, no, they can't, man.
Yeah, dark energy is a force,
well,
and it's
why not WITSIT?
Because they're intertwined.
Why?
Yeah, there's no reason
Yeah,
to think
you said that, but why?
Because the energy is resultant of the matter itself.
The dark energy is resultant of dark matter.
First of all, you're asking me to explain what your priest can't even explain.
No, it's your.
My claim is that the galaxy rotational speeds is the reason that we came up with dark matter, because it showed it was way off. How off is way off? Well, we have a mathematical number from some of the people on your side. They told us what it was.
But
10 to 120th power.
Let me get one.
I'm telling you, that's not what that number is.
What's that number then?
Let me get one thing.
Is a difference between is a issue with the cosmological constant and the vacuum, the 0 point energy, the vacuum energy. Those things are not related to the dark matter or the rotational speed, which is supposed to be a 24%. They say it makes up 24% of. If it were matter, it would make up 24% of the universe or something like that.
So how far off was it?
From what I know, it's like 24%.
Okay.
Let me just WITSIT. So your claim here. Let me just try to explain why. Let me try to argue why it's baseless. And I understand why. Actually, I don't understand. But your point about why you're so definitive on it. It's in my opinion, it's very baseless because yes, there is this unanswered question that people are working on. But the fact that we know it does not, to our knowledge so far, it does not in any way interact whatsoever with light. We don't see any evidence anywhere in the universe with any observations we take ever, or with any telescope anywhere, that this dark matter, this mysterious dark matter, it interacts whatsoever with light. So observations that we make up to this point of light, things that are emitting light or photons that we're gathering in detectors, there's no. If you make a claim that this unknown thing called dark matter is interfering and causing this weird stuff that we're seeing, it's baseless in my opinion, because we know to this point that dark matter does not interact whatsoever with light at all, and light is what we're observing.
But in order for it to interact, you're assuming a distinction between the light and the medium. What if it's one and the same, bro?
So light,
the light itself is the perceivable medium.
That doesn't make sense because we have.
It's just part of the medium that's perceivable because of energy and excitation.
That doesn't add anything at all.
It doesn't make sense. There's no empirical evidence to back that claim up whatsoever. Do
you agree that you do agree that would rebut your problem with it though, right? Because it's not going to interact if it is the medium.
No, it doesn't.
The light's not going to interact with the matter if it is the medium.
Honestly, it doesn't make sense at all. It doesn't make sense at all. How can light be the medium?
Because, dude, it's just like there's a perceivable spectrum of light, or there's a perceivable spectrum of the medium, right? The perceivable spectrum of the medium is light. We're just seeing part of the medium based on the energy that's introduced or the excitation. We're seeing part of the medium being perceivable. It's illumination.
What kind of property does it have that light doesn't have today?
What type of property does it have? It doesn't travel from point A to point B. It's not some physical little particle. It's a coaxial dielectric circuit. It has a rate of induction, and there's an illumination that's perceivable based on the excitation of the medium itself.
There is a
rate of induction.
It's basically an ether perturbation. It's a version or modality of the ether.
Several of those properties that you just listed are incompatible with each other. You can't have all of them at the same time.
Feel free to specify.
The whole medium of space-time can't be coaxial. That's just nonsense.
I didn't say that. The light is.
Which you said
there is no
medium.
Space-time.
Yeah, you're claiming the light is the medium.
Yes, but the perceivable version of it. Listen. The reason that you see light is because you put energy into the medium. Okay, and then the energy you're putting in there is going to cause a coaxial manifestation of dielectricity. It's coaxial, and it has a transverse movement, and it's just the medium becoming perceivable. This explains, instantaneous action at a distance. So...
There is no instantaneous action at a distance. That was the most.
Okay, you say there is none, but what I'm saying is it would explain it.
But it doesn't happen.
Oh.
Well, I say light's instantaneous. I think you misinterpret what happens when we see light. Based on an assumption of physicality within a materialistic worldview confinement that everything's a little physical particle bombarding around. I think that's kind of counterintuitive. And maybe if we're wrong about that assumption, don't you think that we should maybe look into it, or everything else is a futile pursuit? Because y'all claim that not like flat earthers because we deny science. Right, but the point is, that means that you should actually be supporting anyone that challenged the status quo, because that's supposedly what science actually is, right? Bit of a contradictory stance to hold there.
That anything about what we're claiming is counterintuitive with all that.
It is counterintuitive. You told me space and time bend. That's counterintuitive as fuck.
And you said space and is light and is coaxial and is the manifestation.
I didn't say space is light. Space, the medium is light.
Well,
you deny science you don't understand.
I don't like the word space. What?
Okay. Again, you're just replacing words and shuffling them around.
Well, it's the medium, objectively. It's not space. It's not the conceptual privation.
And if you actually study what the photoelectric effect, what Einstein got this Nobel Prize for, and Planck, what he, I think, also got the Nobel Prize for before that, which led to quantum mechanics, and actually the relationship between light and matter, and how shining light on things, and what light is actually reflecting, and all this type of stuff. When you find out all that we actually have learned about what these things are, these kind of questions are a little bit outdated by the fact that they've already been answered and have been found to be irrelevant. Like what you're saying right now about light is not. We already understand these things about what light is.
But you're touting consensus right now, and then in 5 years when it's wrong, you'll be touting the new updates. I'm challenging it before it gets updated, and you're going to hold on to it till it gets updated, and your priests give you the stamp of approval to now change your mind. I don't do that.
I'm not talking about consensus. I'm talking about absolute fact. I'm talking about absolute verified fact.
Well, we'll verify the physicality of the photon then.
That make technology work the way it works right now, and lasers and MRIs and all those other type of the entire field of quantum mechanics.
Verify the physicality of the photon.
Make these things known. They cannot be not true. So we do understand them to the degree that we know that.
What is them? You're just making a vague, baseless assertion. What is them? We understand them. What specifically?
Examples. I said lasers, MRI.
Okay, how specifically does our comprehension of light right now and the current rhetoric is that dependent on being accurate for those to work? What specifically?
Lasers. You need to know the exact wavelength of something so that you can amplify whatever distance that is and make the cavity some multiple of that size in order to actually get the polarized light that you want to come out of the laser. So
who's disputing wavelengths?
You're not going to be able to make a laser.
You
can't have
disputing wavelength. Well, I dispute the interpretation.
The movement of the light.
I dispute the interpretation of the wavelength. Wave isn't a thing. It's just a type of movement. It's an effect. If I get in a pool and I move my hand in it, the wave isn't a thing. It's just the motion through the medium.
And that wave has
a standing wave. You can have a standing wave.
Do you understand that if I wave my hands in the pool and there's a wave, the wave isn't anything in and of itself. It's motion through the medium, right?
So the people who made lasers just got lucky.
No, they didn't just get lucky. So if that's what you got out of it, then just chill.
How'd they make them? How'd they make them then?
How'd they make them?
Yeah.
What a laser is a more concentrated point source of light, right?
You got to concentrate that point source. And
no.
I briefly described how you do that.
See, someone just said no, Coach. You see what I deal with?
Yeah.
Someone said no. Coach knows that what I said was true, and
I didn't.
And he disagrees with me.
Said it was true.
A collimated
you said that you have to get the coherent point source of light.
That's not the only thing.
Well, it's more coherent. That's what a laser is.
Coherent. Yeah, that's a different word.
I said coherent, concentrated point source of light.
Those are two very.
You didn't say coherent, but
which part of that's not true? I did say coherent. This is being recorded. So please stop trying to make me mad or something.
Regardless, in order to do this, you have to understand the wavelengths and the property of light, because you have to.
Thank you. No, that's not true. That's not true.
It is true. It's 100% true. That's
no, it's not.
Laser pens you buy.
You mean you have to already have described and quantified characteristics of light, and then we can replicate them because they happen at the same rate. But the way you're interpreting the quantification is what's in contention, Kosho. You're using the quantification as somehow being proof of how you're explaining it. Those are two different things. That's what we just talked about for like 5 minutes about GR. That's a misconception. There's a difference between the conceptual backing of GR and the math of it. There's a difference in the quantification of light and then the interpretation of it.
Right. So, what was it? Lasers.
Right. And that's
so what the other thing with the photoelectric effect is the other great insight, or the main great insight that Planck had about the relationship between the light energy, or the frequency of the light, and the the electrons, the energy you're going to get from that and stuff like that. And in order to understand, in order to use these properties, the intuitions or insights that you've had in them have to be true, or at least based in truth. And so there's not the fact that we use these things in engineering and we make
Dude, people are scared of there being a background because that almost means like, how'd that get there? But if it's a privation, and there's nothing beyond the material, then you don't have to answer that question or address the possibility of it. But when you say a virtual photon comes into existence, where does it come from? Nothing. It comes from nothing in your paradigm. And
that's not how quantum field theory works.
Okay.
They said that everything is fields, and all the particles are even just excitations in these fields, and that there's a field for every fundamental particle, basically.
The field extends into the nothingness beyond the medium of the air in the material world. The field the field extends beyond the material world.
Fields exist everywhere.
Do they feel? Wait, what is everywhere when supposedly that's nothing? Does it extend beyond the material world? Is there something beyond the material world?
It's in every location, every place every space that there is. Exists these quantum fields.
But is there something beyond the material world, though? Because if there is, then that means the quantum field would be extending into that. If there's not, that means it would be extending into nothing, which it, of course, can't do that. So that's a fucking contradictory claim to say virtual particles or virtual photons are a thing. Is a contradictory claim because it's going to have to come from something, but you say that something's nothing. There's a medium, bro. There's a medium.
These are things you're saying. These aren't things I'm saying.
And in fact, Tesla said this, that whenever the ether was thrown into infinitesimal prodigious whirls of velocity, it manifests as matter itself. And then if the energy were ever to reside, which means even the electrostatic, so that it would never happen, it would actually revert back into the ether itself. Okay. And he said that the ether was thousands of times more dense than the material world, that basically the material world was actually the gaseous form of the ether, and that he knew this because of the efficacy of propagation being relative to the density of the medium, and by looking at sound waves and different frequencies, he knew that the ether was very dense and in the gaseous form of the material, or the material was a gaseous form, which is the opposite of what everyone had thought about ether up until that point. And that's the guy that is the fatherhead of modern electricity we use to this day.
He's not the fatherhead of electricity, but he is definitely
the electrical grid we use to this day.
Yeah, right. So again, what I tell Lemon and what I was telling Gleam earlier is even if what sounds like Tesla was saying is at least the way I'm interpreting it, then it's definitely in the same realm as quantum field theory. Like he could be
kind of sure.
Maybe he's making some kind of assumption about something that maybe ended up being what turned out to be quantum field theory.
Quantum field theory is the reluctant attempt to acknowledge and absorb the original postulation without calling it the same thing and kind of changing it. That's what it is.
It's another one of the most successful. Those two theories are the two successful theories in all.
The most successful theory ever is an ether postulation of a medium.
No,
because it answers and explains all observable. It explains all observable. Listen, you can't name one observable phenomena that can't be explained with it. Name one.
Tell me what the theory is.
Wait, sorry, just name one.
You know what, WITSIT? Even if you were right, they had good reason to avoid naming it ether, because ether has been used for so many different things.
Yeah, that's true. I agree with that.
Being overly specific, you don't know what you're talking about when you say ether.
I agree. Or the only way that
ether, but
right. the light bearer. Isn't it funny that the light bearing ether was removed by the light bearer worshippers? But anyway, yeah, I do agree with you that the only way that would be productive is if this quote unquote scientific community or consensus could agree on the background part, and if we were to ever be able to absorb the word and redefine it more accurately, and kind of do what we do with GR, where we say it's just a working idea. But that'll never happen because ether's like the bad word. It's like running into a church and screaming, "Hail Satan." You can't say the word ether anymore, so they'll never be called that again. But that's what quantum foam is. That's a characteristics of the background. That's all it is.
So?
Well, that's just tomato. But the arrogance of humans have allowed them to not admit that maybe that they were actually right 100 years ago. So we have to call it something different and convince ourselves that we weren't wrong.
Well, we know they weren't right because they did because their version of the ether, if you want to consider the new version ether as well, which, like I said, there's good reasons not to, it didn't cover everything that we cover with current theory. So they weren't right.
No, of course, dude. That was 100-something years ago, dude.
Is at worst better?
No.
I would say completely different.
That's not true because the old theory could at least have the window. Because this is the thing about it, dude. This is it. The medium background claim, right? Like ether, that's a wide opened foundation of interpretation. It's just all it requires is to assume a background. You can interpret it. Listen, it's just a base foundation of a background. That's totally different than assuming the confinement of physicality and the pure existence of the material world only. That confinement is very strict. Ether doesn't have that strict confinement. So all observable phenomena can be explained by it. You'd have to bring up one that couldn't. I promise you can't. I've been looking for it. You have never. Because you don't want to know the truth, I guess. I don't know. But there's not one, man. There's not one. Name one.
Can you stop for a minute?
Name one observable phenomenon.
I'm not going to name anything because I'm going to address an earlier point that you zoomed past. Ether, in its various formulations, when it was considered by the scientific community, was still a part of the physical world. I don't know why you suggested that it wasn't.
So the ether is beyond the material, perceivable world.
Okay, depending on what you mean by material, okay, but then so is light.
It's the background of the material world. That's like the inherent postulation that ether is. Now, many people speculated beyond that. And like you said, many people disagreed on it. Many people disagreed on it, and they constantly changed it, updated it, and blah, blah, blah.
Okay, so if you're going to go with material instead of physical, then the theory that we have now is outside of material as well. It's that nothing is outside of material. Nothing in science is outside of physical. And again, these are kind of fuzzy words.
Nothing outside of the material world.
Talking shit all morning.
Material world is often used as a synonym for the physical world, but not necessarily. And if you want to differentiate the two, then it seems that material would be relating to matter. Would you agree?
Yes, that's how I'm using it.
So, light as it is now is outside of the material world.
Wait, light?
Yeah, it's not matter.
Well, that's funny because your paradigm still presupposes physicality of the photon.
Physical, not material. If we're going with that definition.
Yeah, so it's physical but not material, meaning it has effect within the physical world, so it has to be physical, but it's not matter. So that's a very contradictory claim that you have to hold, but whenever it comes to the ether, I don't have to hold that contradictory claim.
What's contradictory about it?
Look, there's so many issues. Wait, it's inherently contradictory.
How so?
Wait, say it again. Well, this is what it is. I'll explain it. This is what I said. Okay, you're saying, and make sure I'm not strawmanning you, that it's physical but not material because it reacts within the physical world. So that's how we're defining physical in this context, but not material because it isn't matter, right?
Yeah.
That seems very counterintuitive, and you don't have any evidence of that contradictory claim.
Physics is often counterintuitive.
That's somewhat speculative, though, right? Because you're speculating the definition of physical without actually substantiating the physicality
I provided a definition.
That's a presupposed axiom that anything that reacts with the physical world must be physical. Axioms are supposed to be self-evident.
We agreed on.
How can you speculate on a definition?
we have no fucking idea what's in them. We have no fucking idea what they do or what they are. They're just dark regions of space. But we did find out recently that there are galaxies in them dark regions of space.
Okay, stop talking about where you think your fairy tale religion goes to all the way to 17,000 million light years away. We're talking about if there's an ether background.
No,
because the theory of relativity is.
You can't see it. Doesn't mean that it's
I
not
guess
there.
that only certain people have eyes to see. But your paradigm is reluctantly admitting general relativity's flawed. They're going to say part of it is very useful, that the math is still pretty useful. It needs to be updated beyond the solar system, but the conceptual backing is going to have to change.
Because we need
lots of things will have to change.
Relativity, yeah.
Well, you should catch up. I'm letting y'all know for a fact,
science,
that within 5 years to 10 years, general relativity's conceptual backing will no longer be the accepted rhetoric.
Well,
and then, all of a sudden, when I come in here, y'all will start arguing the next thing they tell you, but you'll never say, Austin, you were right for 10 years.
Austin, we're telling you the same thing. We're saying the same thing. Everything's going to change. Every single theory that we have, the nature of science is to either improve on it or to correct it. It's all going to be different.
The whole conceptual backing is going to have to be replaced.
All right. What specifically do you mean by the conceptual backing?
The causation claim. The causation claim of space and time bending and warping due to the relative relationship of the mass layout in the fabric that causes gravity wells. That's the conceptual backing.
We're clearly on the brink of a scientific. It's like, let me just get one thing in it, which is that. Let me get one thing, which is there is a scientific revolution that happens every so often, and Einstein was one, and thermodynamics was one, and we are apparently on the brink of another, having to do with gravity and our understanding of cosmology. That does seem the case, and we're going to have this breakthrough in gravity that's going to come sometime in the next 5 to 20 years, and it very well may undermine or rewrite or completely revamp relativity and quantum mechanics, or it might not. But it's going to have to change something, because it's in order to get things to work, something's going to have to give. And that's fine. That's like science is telling you that. Science has always been telling you that. It's the nature of science. No one's trying to hide that. No one would try to deny that.
But Scott, if that's the nature of science, then why can't we entertain other possibilities then?
We can. We do all the time.
Well, how come whenever y'all just hear the word ether, y'all assume that you can't even talk about it because you think your priests hate it, but actually they are on my team. They just call it a different word.
I think we've all said that. It's actually a thing before.
What is quantum fields? What is quantum foam? What is quantum energy? They're all characteristics of ether.
There are all ways in which ether is making a comeback in different forms. There's no
exactly, bro.
People
right.
say that all the time. We've said that all the time.
Okay, well, that's my point.
Hold on. You put onto us things that we don't actually say or do. You put onto us constraints that aren't really real. Like we've said the same thing.
No. I think that when y'all are here, y'all probably have a pretty cool conversation about stuff like, basically, this is just the ether. They don't want to call it that. They're gonna, But when I'm here, since I'm a flat earther, whenever I bring up ether, everyone has to they feel like they immediately have to defend general relativity to the death. That's what happens.
That to the lemon for 2 years.
Well, what's ether?
Ether and quantum field theory. So I don't know.
Okay, there's what is there 50 people in here, and Kosho's the one exception.
Wait a minute. Now you're talking like you agree with us and using different words, whereas earlier you were talking like we were completely wrong and you were presenting a completely different idea.
No, I do. I vehemently disagree with you.
I know you do.
Because your religion says space and time bend. That's on its face stupid. And I'm not going to sacrifice. This is what I have to happen. Seriously, this is what would have to happen. I would have to say I can't trust my competence. I think I can't trust myself. I'm not smart enough to think about this myself. I'm going to have to go against what my cognitive ability says, what my hyperlogical deduction says, and trust them. I'm not allowed to think for myself if it doesn't agree with them. And I'm stupid for not doing so. And that's the most people said that to Tesla, dude. Nikola Tesla was told stuff like that. I mean, and I'm not comparing myself to Tesla, dude. No, that's not what I'm saying. What I'm saying is just like, dude, you should be allowed to question things, man.
Allowed to, but as you said yourself, you're no Tesla, man.
Why do we use Tesla's ideas today then?
Because you came with the AC generator.
It's not like evidence of that we are actually listening to what he's saying. We don't care so much.
No, it's not, because we use the AC generator and then we just ignore the very foundation in which he used to create it.
We don't.
Sometimes it's okay. It's okay to be proud, as you said, and it's okay to be verify things, as you said. But it's also probably more often than the other case. It's important to be humble when you need to be, and remember the efficacy in other people's information and how important it is to have that as a resource. To have
Dude, I listened very intently every time Chronic spoke because I could tell that he actually had knowledge on the subject, and he wasn't trying to divert. He wanted to have like a fair back and forth where we were actually being honest and responding with specificity. Most of the time that doesn't happen. But anytime that happens, bro, I keep it cool, man. I'm interested in this stuff. I'm like a nerd, but I'm not going to deal with obfuscation and name calling and not stand up for myself, dude. And that's where it devolves.
Honestly, being honest is overrated.
Your comment.
Oh, yeah, sure.
What you're saying about trusting in other people's work and stuff like that.
Yeah, of course. You shouldn't just exclude other people, is what you're saying, because of course not. But y'all shouldn't exclude my opinion on things, or not just mine, but anyone in my position, because you have a different cosmological interpretation, right? That doesn't mean everything they ever say is invalid, even if you were right and they were wrong, right?
Why not?
Yeah, you're right.
If someone speaks absolute bullshit, why not just say it's bullshit?
Okay, but
it's bullshit, Branch, what you just said.
All right. See, I'll say fine, it is. But like, for example, let's say you're trying to explain to your kid why they should brush their teeth, and they gave you this entire explanation as to why it's okay not to brush their teeth. Are you going to dismiss that as bullshit or not?
Dude.
Well, it depends what they say.
Good point.
Maybe they came up with a brilliant reason why you shouldn't do it.
Exactly. He's like, look, there's fluoride in that, Mom and Dad, and it says that if anyone swallows that, to immediately call poison control.
The chances are is that they're not going to be able to do that, right? There's no child in history
that can read.
The great excuse as to why they should not brush their teeth.
Yeah, watch a child that can read. He looks at the back of the toothpaste and it says, "Do not swallow. If so, immediately contact poison control." And he says, "Mommy, why am I putting something in my mouth that if I accidentally swallow, I have to immediately call poison control?"
Because you don't swallow it, you spit it out.
Yeah, but he's just a little kid, and what if he accidentally swallows a little bit? And that's actually a logical thing he could ask his mom, don't you agree?
That's why you get the kids version where a single dosage isn't enough to cause poison control.
Or you just don't get fluoride in your toothpaste.
If a kid's
fluoride is so useful.
Fluoride is so useful for calcifying the pineal gland.
And for giving us good teeth. You clearly haven't traveled abroad if you don't think fluoride is useful.
Well, I think that we as Americans, we just take better care of our teeth all over. We have straighter teeth because we take our wisdom teeth out at a higher rate. Did you know that? And white people are the ones that have to do
nothing to do with the topic.
White people have to. It was just an analogy, man. It's so funny. You don't ever call your own side out for bringing up something nothing to do with the topic. So that's so funny. Double standards.
What?
No, on occasion, like a few people in here will be like, "Branch, we were actually talking about something," but it's whatever. So let's just move on, man. Do we agree though it's possible, in fact, that general relativity is completely wrong, and that Tesla's postulation was like 100 times closer to being right? Is it possible?
Seems like.
Yeah, did Tesla's postulation provide any of the verified predictions that we've?
Well, it had the same math, so yeah, it would have.
Math?
Yeah. So Tesla, whenever he was Tesla didn't actually create a definitive model, but he was going to. The government clearly took it, but he said right before he died that he had a dynamic theory of gravity that would definitively dispel the nonsense that was space curvature. And then he died within a year or two.
He also said that he would love to paint pigeon and that he had a death ray.
No, he didn't say that. In one interview, he was asked about a pigeon, and he told the interviewer that he had a dream where the pigeon came to him, and she was super nice. And one of the only times that he felt like someone could actually understand him, and that was misconstrued. So somehow he was a crazy person that wanted to fuck a penguin, or fuck a bird. Yeah. Anyway, so you see, the story's not actually what you said it was, though.
Even the other part, the part you said, I wouldn't say it's sexually crazy, but
No, it's kind of weird, but you understand what he was saying. But he was explaining that it was like he thought it was a message in his dream where, like, it's okay, there's something majestic, there's a reason, because other humans, he didn't feel like he could really relate to that much. That was the point of the dream.
This is a real life pigeon hung out with, though. Like, it's not a fake pigeon.
It's a real life pigeon.
No, it wasn't a singular. That's not true. So he liked pigeons. Sometimes he would go to the park a lot, and because he felt like pigeons, he didn't like humans that much. But it wasn't a particular pigeon. Pigeons always came to his down to his porch. He always used to go to the park. The report.
When I read the report, I'm looking one now. They do say it's a particular pigeon. Now they may be wrong. You may be saying
You're right. Yeah, it is wrong.
They do say it that way.
Why did they throw dirt on that man's name? That's the real question.
I think because he was weird at the end. I mean,
but why don't they throw dirt on Einstein's name then when he was objectively weird and he married his first cousin and then wanted to have sex with her daughter?
A lot of people.
He wrote about how he was sexually attracted to his daughter, his stepdaughter.
Well, our president says that he would have go out with his daughter if he wasn't his daughter. People say.
How do we know about that? Because some of us individually went and looked into all of his journals.
Because it's been published, and so
he was also an openly ethnic supremacist.
Was he?
Yeah. Have you ever read his quotes about ethnic supremacy?
No.
Dude, the most blatantly ethnic supremacist shit you can imagine. Well, he's part of the chosen people, and he's ethnically superior, and he explained how they needed to control with eugenics all the different races. Yeah, Albert Einstein. He also liked to wear women's clothes. He was a very out there person, man. And my point there was, if we throw all kinds of dirt on Tesla with a story that isn't true, why don't we ever get taught on the mainstream about how Einstein was a crazy, creepy little grabbler with a small IQ and a low mathematical competency that wanted to have sex with his daughter?
It sounds like we do if you know about this. And in fact,
I had to research the crap out of this, dude.
I did a search just to see what you're talking about, and I mean, here I am on a Scientific American article. It says, "Was Einstein racist?" And it says, "Looking through his diaries, they do contain shocking detail." Blah 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 blah. So it clearly got reported.
Yeah, and he was very misogynistic, and okay.
Like he called the Chinese.
I don't even like the word misogynistic. Oh yeah, exactly. I don't even like the word misogynistic, but he was like what the word should mean. Now it's tainted in modern society, but like he was kind of ridiculous. He told his wife that he didn't really listen. He told her. I didn't really care about personal contact, that personal interaction. He only wanted to talk to her whenever he allowed her. He would specify, and that she was to constantly cook this many meals a day, make sure that she had this done, and to only talk to him whenever he wanted to go talk to her. He was like that.
Some girls like that. But
back then they didn't have a choice.
My statement is to call him low IQ, though, you wouldn't call either one of them low IQ. That's just silly. They're both geniuses, no doubt about it.
What was his IQ?
Who knows?
I have no idea, but you wouldn't call him low IQ.
I heard he had the lowest IQ in his class.
I mean, even if he did, he's a genius.
Well,
and that low IQ
what makes him a genius is the part that makes him a genius saying that two different conceptual abstractions can fucking bend and warp. Is that what makes him a genius?
Yeah.
Einstein said that
hold on. Oh my God.
Go ahead.
The thing that makes him a genius, to answer your question that you asked, is to have the insight to come up with the completely counterintuitive aspects of relativity, to think about things in such a way that he was able to lock together into place a lot of things that we knew, a lot of equations that people have been working on, and to see the big picture in a way that nobody else could see, that then reconciled all this experimental data they had that was contradicting at the point.
No, it wasn't the way that nobody else could see, because he took everybody else's shit.
They all give him credit.
Including the very idea of space-time itself.
They give him credit, though. You read these quotes where they all recognize that he did the thing that none of them could do.
The dude
that's actually not true. So some of the people came out and said that he stole their shit. Two different people came out and said that Einstein stole their shit. Einstein came out with his final product a week after one of the major mathematical parts was released, 1 week later.
So his peers consistently, if you read these interviews and read these quotations, they support and give him credit for the insight that he had. Now, maybe somebody complained that he took something of theirs without asking or something. I don't know. You have to show it to me. But as a general rule, he was considered a genius then, and for good reason.
Okay, well, I will say, for one, someone can have a really high IQ and be a dumbass. But in addition to that, like, he didn't have a high IQ relative to any of his peers. He actually didn't pass the original mathematical competency test to get into engineering school. He then worked as a clerk at a He then worked as a clerk at a patent's office. Okay?
I don't know if that's true.
It is all objectively true, dude.
He was trying to get.
I think you have the story.
He wasn't very good at math. It's not.
Disputed. His genius, the genius attributed to him was, again, like his conceptual ability that you just described. But trust me, his mathematical competency is recorded to be shit.
I think you've taken a myth or a meme and you've misremembered something about it.
No, Scott, I did a stream on my YouTube about it. If you want to go look at it, it's called Einstein. It's like number 18. I literally show all the documents. All of them are linked under the video.
I say he wasn't.
I'll just look it up.
Comparably to his contemporaries, in the sense that he was a Nobel Prize physicist, but it's just also not uncommon. Like I said, Neil Bohr, he was a terrible writer. He didn't write his papers. His wife did, and so Einstein, having his wife who was great at math help him do some of that stuff, is not that.
Well, yeah, of course, and plus another better argument is that, like, whenever you have a higher aptitude, like a really, really high aptitude in one certain field, sometimes what correlates with that is a drop off in other fields, like beyond, like, basically like remedial or just like mediocre competency, because your aptitude exceeds in one certain field. That seems to be a reoccurring thing. So that would be how I looked at him. I had him up on my wall. I had him on my wall. I put prominent people I respected on my wall all across in posters, and he was one of them. So I don't dispute that with the official narrative he did something cool, but when you look into it, he was a creepy dude, bro.
Yeah, but nobody knows him for his sexual prowess or his personal love life
or racism.
He's known for the insight that he's given us in the field of physics and stuff. So,
yeah, of course,
yeah,
of course.
Really,
the only reason that came up was because someone started talking about Tesla personally.
Well, no, but just because you were using Tesla's quotes on what, and him saying these things about Einstein's theories and that about it being foolish stuff, and that's when Sky had said, well, he also said this stuff too. So it's
okay, really... well, but what he said was that basically some of the people are actually brilliant minds that are behind this, but they wander off in mathematical fantasy, that their mathematical garb is basically like a beggar clothed in royal linen that fools mistake for a king, and they are actually metaphysicists. They're actually metaphysicists. Yeah, and then wait, I'm almost done, dude. Tesla knew they were metaphysicists. And then there were like 100 different scientists that were Nazi and Austrian scientists that all got together and said, Einstein, we got to get rid of this dude. He's trying to wander us off into mystics and metaphysics. And now when you look at it, it is metaphysics because it's an ontological premise of concepts, space and time.
Yeah, but it's so predictive. We have so many experiments to confirm it.
The math is what's predictive, and that predates space and time concepts, dude. You don't even understand things.
Itself doesn't predict anything. Okay, it doesn't.
Oh, wow.
The math is just a tool that the physics is using. You have to have the physics and the explanatory ability of it. But
wait, you need the explanation to the mathematical deduction?
It's not math that we're talking about. We're talking about actual physics. But anyway,
we're talking about making predictions and stuff. Then you need the math. Yeah.
These guys that we're talking about that you just said Tesla was talking about, like Niels Bohr, Richard Feynman, Einstein, all these Paul Dirac, all these people. They weren't experimentalists or engineers. They all were theoretical physicists. So all these ideas that we have about quantum mechanics are all based on exactly what you say Tesla was warning us about or critiquing them about.
Well, he said, no, that's not true. That's not true. Because what he said was the most crucial part was experimentation. He said these people don't do any experimentation. They wander off in mathematical fantasies. But quantum mechanics is very experimentally valid, right?
Yeah, I know, but those guys...
By the way, can I...
Oh, sorry, I misunderstood you.
I looked it up, and he didn't fail the mathematics stuff. The most thing I could find was that he didn't get into Swiss Federal Polytechnic because of not reaching the standard in the general part. But on that test, he obtained exceptional grades in physics and mathematics. And other than that,
what was the score in mathematics then?
We passed it next year also.
I know he passed it next year.
Physics and mathematics.
Boy, okay, so that's just a claim. That's not true.
Well, it's yes.
If I have to go
find
mine
is at least evidenced.
I think I might already have it saved. And if I do, then would you be honest? It's
please.
kind of odd that they would say it like that if that wasn't true.
Sure. If
you would agree it'd be weird if his math score was actually low.
Well, yes, if it wasn't exceptional as per this quote that I'm just giving you, yeah, sure. Do you have a source?
I'll find it a sec, bro. I mean, I'll show you. I think it's on YouTube, but I'll have to find it.
Only the first time that he didn't get in, but the next year he got in.
He got in, yeah. He got in next year. There's no doubt. But I mean, dude, come on. I mean, you should be able to just pass the entry exam to a school, right?
Wasn't that like to get his doctorate, though, his PhD?
No, it was different back then. I think it was just to do that, right? Like I don't think there was college for him. It's weird. It's like I think it was just different.
Yeah. So what I'm saying is, it's an entry exam, though. I mean, I will say the quality of the entry exams back then would have been much higher because of the fucking depravity that we've sunk to now. Because if you look at like the gradings, even the scoring system of when Tesla and them were alive, it's so much better. It almost makes you feel dumb just reading their grades, like just their scores. You can tell because you can read the subjects. You can read the subjects, and the subjects are so much better than anything we have, even in supposed higher university now. It's wild.
There's a YouTube channel where PhD students take tests that were from like a mathematician will take a mathematics test from 1921 for PhD student in 1921, and they're always insanely hard and weird and just like it's just weird to see how education has changed. And
there's also a YouTube channel that this girl, she looks at a bunch of like historical prominent figures report cards, which is where I saw this.
Really?
I was talking about. Yeah, it's pretty interesting. It's pretty. I'll have to remember. It's very. You can probably just type something like that in YouTube, she'll pop up. But I've seen she did Tesla and a few other people. But it's pretty crazy. What's interesting is the way the scoring system's set up, and then like the name of the subjects and like how it's set out semester to semester, etc. It's pretty wild. I just think that we've lost a lot of, dude, the average person under 18 can't even write in cursive. Not efficiently.
I can't anymore. I mean, why would you write cursive?
Well, what I'm saying is it's shown that under CT scan, when you write in cursive, your brain like just lights up like a Christmas tree. And in fact, if you learn to write cursive ambidextrously, then it also lights up more on the other side of the brain, but it's on the inverse side of the handwriting. But dude, I'm just saying it's a much more elegant thing that we can't even do anymore. It stimulates your brain, like you can prove that. So I just find it odd that now, like, one thing I think that's really crazy, it's gonna get to the point where like people can't even read the founding documents of the US. They're not even gonna be able to read their supposed rights anymore.
Well, they're already. I mean, I think I'd say they're already at a reading level that most people don't have naturally. I mean, they're hard to read, I think, for most people.
No, yeah, you're right. The way they're written alone, right? But if you can't even if cursive looks foreign to you, you're gonna really not be ready to try and interpret the context of the founding documents. That's a ad hoc theory, but I mean, I'm just saying.
I'm just thinking about it though. What we do have now that we didn't used to have is we have think about well, here's a weird factoid is that the Army says that accuracy in new recruits for shooting has gone up steadily since 1995, and the best guess is the reason is first person shooters. But maybe a more generalized thing of that is that we have all these other ways in which we test and challenge our brains that we didn't have before, like via computers. We have all these puzzle games and puzzle things, and we have access to all kinds of information that we wouldn't have.
Pros and cons.
I kind of suspect, that the trade-off is actually in our benefit.
Yeah, because you can Google the Constitution and read it in just English. You know what I'm saying? Just a print. So yeah, there's no doubt. But I think that also that's kind of blinded us with arrogance, and we've kind of wandered off in some pretty unfounded fairy tales.
The ancient person, like the prehistoric man, I'm talking about like hunter and gatherers, even before that those people on average were smarter than people today on average, for exactly the reason that you're saying, because they would have all these skills that they would need they wouldn't have things that they wouldn't have different jobs for different people. They would kind of have to know how to do all the different shit themselves, like how to make this tool and do this thing and do all that. And, if they wanted to be successful. And when I say smart, I just mean the amount of information that they need to have stored in their head, and the capabilities that they would need to have. But at the same time, they lost those things over time because of what we traded that off for, which is a smarter and a more efficient kind of intelligence, where it's kind of what we're doing now. Like we don't need to know these things or know how to do these things or how to or remember these things or whatever, because we have them in your hand or whatever. Like you have them on your cell phone, you can look up a recipe. You can
Well,
learn how to
yeah,
do
but
this, do that.
it could end up being one of our biggest detriments, like
Sure,
because if that was to ever get pulled out from underneath us, we would have no idea what to
Yeah,
do.
you're right.
But back then they would. But also, I will say, I'm sure that I'm a crazy conspiracy theorist to you guys, but I think ancient civilizations were significantly more advanced than we've been led to believe. I think there were peaks and valleys of advancement and societies and stuff like that. But I don't also think that the Victor's the author. We don't know the exact timeline. I think that they're already laying the foundation to kind of admit that these civilizations actually were pretty advanced. And then ancient aliens, I'm sure y'all think that's stupid, but then the FBI comes out this year and says they've seen UFOs, and then all this stuff, and archaeological discoveries don't seem to be consistent with the notion that they were super primitive. I mean, like a vase, something as simple as a vase, like the simplicity of its place in society back then or any time is overwhelming. It's just a vase, but the angle can't be replicated to this day. And so that's kind of where I stand on that. I think that like we have been tricked to think we're at the pinnacle of like technological advancement and efficiency of humans, and I think that people back in the day were very, very like advanced relative to what we were told.
Sorry, I missed part of that. What was that? An angle on a vase can't be reproduced?
Yeah. There's like a vase I believe it's found in Egypt or
I think I
Baghdad.
know what you're talking about. It's that one. Is it the vase, or is it is it etching of a vase, or what they think might be a vase?
Yeah, maybe something like
somewhere,
something.
yeah.
What's
But
unreproducible about it? I don't get it.
The angle of it, the interior angle of the vase.
Maybe I'll find the picture I'm thinking of and see if that's what you're talking about. Because, like I said, it's not necessarily like a vase. It's not a vase that he's. If it's what I'm thinking of, it's like a sketching or a what do you call that? Like a imprint of like a guy holding a vase, supposedly holding a vase. But I think the reason they think it's not a vase is because of the actual angles of it or something like that. Unless you are actually talking about a vase.
There are things in the past, the artisan objects in the past that we have lost the knowledge of how to craft. Like, well, remember how long it took us to come up with a very clear idea of how they would have built the pyramids, and
Yeah.
I can't remember. I can't remember exactly what the example is, but there's some techniques for like making copper weapons, or I'm sorry, making bronze weapons that maybe we look at the distribution of the metals and we're like, how do they? I think maybe we have an answer, but it took us a while to figure out how the hell did they do that. And even now, where's that? Isn't there a South American wall where the stones are put in there so perfectly that
yes,
that
those are everywhere,
like,
bro.
how do they do this?
The masonry was insane.
Oh yeah, I'm not surprised that there's some tricks that we don't know for how things were made. It was just the angle thing caught me off guard.
Oh yeah, but I mean even like the precision of some of these structures, like the precision of like the drill of some of these structures, like the precision in which they're drilled or engraved is like something we can't understand how they did. I find that to be like wild, like that we can look at those things that are so self-evidently there. They're there, and just immediately assume there's no way that they were anything but like primitive people, and they had nothing better to do. So the reason this is so hard to replicate is because this is all they did or something. Like,
yeah, exactly.
It's a bit of a backflip for me, man.
But I think there's some truth to that, which is that there was probably allowed to dedicate a huge percentage of their time to a very specific task that we just don't have anyone doing anymore. Like nobody's going to be dedicating their entire lives to figuring out how to like cut limestone in a certain way.
Well, of course, we found the batteries from back in the day, and then every time all of their depictions, they tell us that they're all just primitive mythological representations of things, but they would show them holding like what appears to be like a light bulb, and they would show these different hierarchical representations. They told us all were just metaphorical, and I'm not saying that they were all literal or anything, but they have things in there that like the lights. They were walking around with like lights in their paintings. Now, we are not told that they walked around with lights for real, And so it's just
torches,
crazy.
they walk around with torches.
And we, what's up?
They had torches, right? They would walk
But it
around
wasn't a
with lights in
torch.
their
It's
hand.
not a torch though. They don't depict
Or lamp.
torches like they. It's a little little bitty bulb looking thing in his hand, and it's nothing. There's
That's
more
what I
than
thought
one.
you were talking about when I said that earlier. The vase. That's what I was thinking of. Those. It looks like they're holding something like a light bulb sort of thing.
Can they just be gas lamps? Like the way the Egyptians had?
I can't remember if the vase said that. No, the Egyptians have depictions for sure. I can't remember if the vase depicted it, but I do know that numerous times in the Egyptian civilization it shows it. Yeah. But anyway, all I'm saying is like it is possible, in fact, that the pyramids could have maybe been used for energy, man. And if you could create a resonance, right, then you could have like say a light bulb that would just light up when you're touching it, when you're holding it. And so they had the pyramids built, and then they had like copper tight chamber to chamber interaction. They used gold, which has huge, like very efficient magnetic permeability. They had water underneath them. They had chambers that dropped off. They told us they were tombs. There were nothing on the walls in there. They're barren. So it seemed, yeah. Look at that. Look what Coach. So I'm telling you, yeah, that's one of them.
The dendrolite bulb.
Okay, well, truth is stranger than fiction sometimes. Yeah, I mean, boy, Mark Twain.
It's also difficult to try to interpret these things.
The pillars,
because we're pretty good detectives going back there, but you had to imagine
the pillars were the pillars of Jed. They were Jed pillars, and they were made up of different stones. And that light pillar, that light beam or whatever it is coming out of it, it's not really a light bulb. It's more of like an offering to the gods to tell them that that they're going to get up the next day.
You're doing what we just talked about, which is they just try to tell us what they think they really meant by it, right? Like we don't really know what they meant by it. Like if we're being honest, there's so much we're detached from, so many factors.
I agree, yeah.
Right, like we don't really know. I mean, and if you look at all these other people, they had a whole bunch of stories that they kind of correlate. I don't know. I just think that it may be bigger than we've been led to believe, or not even if it wasn't some crazy little concerted effort. Maybe it really was lost in time.
Maybe
but
it was.
We don't know all the shit that we claim to know.
No, we don't. We don't know half of it. Half of the shit we think we know we don't, and half the fucking shit we do know is fuck all. So yeah.
Yeah, for real. I think that's the most important part, like acknowledging humans' inherent ignorance, and trying to keep an eye on arrogance, as in as a people as a whole, where we think we got it all figured out, because we don't, and then we're not gonna ever really figure more stuff out if we think like that.
Maybe another 1,000 years we'll figure it out.
Maybe, yeah. I don't know if y'all's paradigm, your little paradigm's real somehow. I mean, it's not. I promise it's not. But let's just say that it is. Maybe the aliens will come back, and tell us all about it. They'll be like, "Here's the real timeline," because it seems like that's what they're setting up the narrative of. So maybe there you go.
You should say it's the real cleanser.
Well, like you said, truth is stranger than fiction. Maybe we're just right.
There are intergalactic extraterrestrial aliens. If there are motherships or UFOs or anything, there were archaeological discoveries. That's my opinion.
If all the fiction is true, we're fucked. You do know that.
Yeah, because there's an end game in almost all of them.
It's gotta be an end game.
Yeah, you're right. You're right. But humankind doesn't really seem to be making a huge case for itself anyway. I hope that's not true. I hope we get our shit together, but we just blindly just bent down to our knees in unison as an entire world when all of the authority told us to. As the whole world did it. And it was trauma-based mind control and fear, and I understand some people might want to try to justify the fear, but I'm just saying, we need to get our shit together. And depravity is exponential. It's getting ridiculous. Now pedophilia is being normalized in society. Now we're not really taking care of the earth too particularly great, and we need to kind of get ourselves together.
Houses, mate. Fucking hell. Until we get that bit fucking worked out, we stop fucking tripping up over our own asses, then we're never going to get any further forward. We're not going to fucking progress with anything because everyone's so fucking excited about consumer fucking shit at the moment. Consumer this, consumer that. I mean, when that dies down, we might get into some like proper research and fucking archaeology, apparently, eventually. But no, they're too worried about me at the moment. It's all about me, innit?
Yeah, and they got so distracted. It's like, get money, pay your bills, then you have whatever you do, like play games, Discord, Netflix, TV, whatever it is. You just go in these cycles, and we get so caught up in that you don't think people don't think about anything other than that. And like you said, they've made it centered around us, where we have this phone, and we're just have this inflated feeling of self-importance because of some persona on the internet or through
I've
the
got
ether.
an iPhone, I've got a smartwatch, I've got a fucking computer, I've got a server, I've got a fucking this. All right, we do it for ego, but you know what I mean? It's like, I don't know, it's just all consumer crap. You can't take any of it with you. It's no fucking good to you when you're dead, so I don't see what the big fuss is all about.
Well, I'm about to get out of here. But I'll tell you guys, man, look into the ancient civilizations, they were more advanced, in my opinion. It seems like they're kind of reluctantly coming out to disclose. They're making the idea of disclosure mainstream. And say that they come out and they tell us about these advancements, but they were visited maybe or something. I don't know. But don't necessarily just believe whatever they tell you. Just look into it. And if all of these ancient civilizations were actually more advanced, or at least some of them were, and they all knew the nature of the Earth being geocentric stationary plane, I don't know, something about, because if they did have something like a UFO, they're not gonna fly that around
I tell
any
them
type of
all the time to do
efficiently
their own research.
without knowing the nature of the Earth. But
Yeah, I tell them all the time to do their own research. That's the only way you're going to find out. And then you make up your own mind. I know it's going to make it even more confusing, which it always does, but then you've got to like take all the rest of the confusion into it and fucking make up your own mind about what you think it is. And, you can ask other people about their opinions. And if their opinions are different to yours, then yeah, they are. But, it doesn't mean to say that you have to take that opinion. It's up to you. It's how you interpret that opinion, I guess, at the end of the day, yeah.
right, and really, the best it should be that worst case, it's just gonna sharpen your opinion. All right, I'm gonna catch up with y'all later, man. Peace out, much love.
Take it easy, man. Damn it, Tao's the WITSIT whisperer.
Yeah. Seems like he's got a brain in certain subjects, in certain areas. It's like we all do, and then we try changing the subject, we try going on to something else, and it's not really within our fucking research, fucking, what they call it, circle.